Hey there, thanks for watching this video here on solving nonlinear inequalities. Actually, we're not really going to do all kinds of nonlinear, we're just going to focus on quadratic inequalities, things that look like this in the algebra, x squared minus 6x greater than 0, or maybe less than or equal to 0. That's what this video will be about. If you thought that maybe you were looking for some help doing math where you graph something and then shade one side of the graph or another, that's not what this is about. So if you're looking for that, I'm sorry, this won't be the video for you. But if this is what you want to do, then let's proceed. We'll start with a little example here of a quadratic expression set greater than 0. So that's a quadratic inequality. And what we're going to do here is find all of the x values that make this a true statement. And when you're solving an equation, you get a number, or maybe in a quadratic equation, you get two numbers. But for an inequality, what we're looking for is all the numbers that make that statement true. So we're looking for a big range of numbers, perhaps. Okay? So the first thing that we're going to do is actually kind of pretend that it is an equation, and we're going to solve it. All right? And that's called finding the critical values, or sometimes they're called zeros, sometimes they're called boundary points, sometimes they're just called x-intercepts. All of that stuff that we do to solve a quadratic equation, that's our first step here. So hopefully you are already pretty familiar with the process of solving a quadratic equation. All right? So in this case, it looks like that. We can factor that pretty easily, and without too much work, we get answers x equals 0 and x equals 6. All right? These numbers are what we're calling the critical values for this inequality. That's a phrase that a lot of math books use and a lot of other math materials use, critical values. But boundary points or zeros or roots, they all kind of mean the same thing, the solutions to the equation. All right? So we're done with the algebra, as a matter of fact. What we're going to do next is a little bit different. So what we're going to do is take those two numbers and put them on a number line, just like that. So we got 0 and 6. So 0 goes on the left, 6 goes on the right. And what we're going to do next is choose a number in between those two numbers and test it in the original inequality. If we get a true statement by doing that, then we've found the solution interval. If we don't get a true statement, then maybe we have to keep looking. All right? So that's how it works from here is once you find those critical values, you're just going to take a number and test it into the inequality. Let me show you what I mean. So let's say I choose 2. That's in between 0 and 6. So if I take my original inequality there and replace the x with 2, kind of work it out here a little bit, simplify the whole thing, and I get negative 8 is greater than 0. Well, think about that. That's not true, is it? That's a false statement. So that means that all the values between 0 and 6 are not part of the solution, all right? So we didn't find the solution yet, but at least we found an area that doesn't work, so that's also good. So what we'll do next is try another couple of numbers. We'll try a number on the outside of that central interval there, like a number less than 0 or a number greater than 6, and we'll put those numbers in to the inequality and kind of test them out, and you'll see with a little bit of work there that in both cases we get a true statement. So that is that's our solution intervals there. Both of those statements are true, so that means that all the numbers that are less than 0 and greater than 6 make that inequality a true statement. So we've kind of found our solution. These critical values, this is why people call them boundary points sometimes, because they are literally the boundaries of the solution region on the number line. All right, so so that's what it looks like on a graph there with those little open circles. You may be familiar with that type of a graph there with the open circles being strictly greater than. But when we express our solution here, we can use inequality symbols. So it's x less than 0 or x greater than 6. All right, those are our solution intervals. And the interval notation style of saying the same thing uses parentheses and the infinity symbol and that little letter U in between there that stands for union. That you can use that, or you can use the word or. It doesn't really matter. But that's what it looks like to say that same thing with interval notation. All right? Let's try another one, kind of like that. Let's see how this goes again. So there's another inequality. quadratic inequality, and this one solves pretty nicely also by factoring, and we get answers, our critical values there, x equals 5 and x equals -2. Alrighty, so let's put those on a number line. Let's test a number in between, like 0. 0 is a really nice one to test. It works out pretty quickly there. We get -10 is less than or equal to 0, and that is true. So just like that, we've found the solution to this inequality. It's all the numbers between -2 and 5, inclusive, sometimes we say. It's -2 less than x, less than or equal to x, and less than or equal to 5. The interval notation style for that same statement looks like that, with the squared off brackets indicating that those two numbers are included in the solution interval. All right? So I think one more example will do it. Let's try this. It's written in kind of a slightly different form. You might call it vertex form for that quadratic, but no difference really. We're going to just do the same thing. We're going to set it up as an equation and then solve it. All right? And this not too bad really. I can do a couple of quick moves there by like subtracting 10 from both sides and then dividing both sides by -2, and I get that x minus 5 squared equals 5. Okay, so now I'm just going to take the square root of both sides, and don't forget that plus minus there, because we do get two solutions here by solving a quadratic, and there they are, 5 plus or minus the square root of 5. That's an irrational number. All right, so just to kind of get a mental picture of it, I put that into a calculator, and I got x is about 2.76 and about 7.24. That's handy because when we put those numbers on a number line, it's now I know I can pick a number in between them very reliably, and I think a number that might work out well for us is the number 4. So I'll take 4 and put that in for x in the original inequality. All right, so now we're testing the number 4 to see if it gives us a true statement. And 4 is nice. It works out pretty nicely there. We get 8 is less than or equal to 0. Well, nope, that's not true. So that means then our solution is the two intervals on the outside of that region there. So in other words, numbers less than 5 minus root 5 and numbers greater than 5 plus root 5. So we can write our solution then with interval notation like this, with parentheses -infinity comma 5 minus the square root of 5, or parentheses 5 plus square root of 5 comma infinity. That's how you can write out the solution for that with the interval notation. All right, so that'll do it for examples on this. I do want to make a comment here that I have another video that uses graphing to do this same thing. If you're had some practice graphing parabolas, that is a very nice and direct way to get the solution to some of these inequalities also. All right, so check that one out, and thanks very much again for watching this one. Okay, bye-bye.